welcome back. Let's do theorem number 6. The one that states that an exterior angle of a cyclic quad is equal to the interior opposite angle. What do we mean by exterior angles? So we know that in a triangle, we can find angles inside it. In a square, we can find angles inside it. In a whatsoever shape that has vertices, we are most likely to find an angle within it. So let's say now, let's make an example with a triangle. Say this triangle, this is your life. Let's say this is your life and you are with whoever you're with, dating someone, and they decide, or you decide to take them out of your life. You see, you had 3 angles. Now when your ex goes out of your life, or when someone goes out of your life, they become what? Your ex. And then now, since we're dealing with angles, this angle that will be formed here is going to be called an exterior angle. So this is an exterior angle of what? Of the triangle. And then let's say we have this shape, a cyclic quad. He takes his x out and then he has what? An exterior angle. So now let's go to the proof, or let's explain what this statement means. It says that this angle, if we can look at the diagram here, we see that A, B, C, D are vertices of a quadrilateral. All the vertices, they lie in the on the circumference of what? Of the circle. That means this quadrilateral is a cyclic quad. And then now we have an exterior angle of that cyclic quad, of which is called, we have it as D2. So this statement here says that D2 is equals to the interior opposite. So the interior opposite is this one. So this theorem states that this angle D2 is equals to angle A. So we have to prove that angle D2 is equals to angle A. Okay. Now what we are required to prove? We are required to prove that angle D2, or you can just not write this thing, put the cap on top of the D. D2 equals to the whole of angle A. So let's jump into the proof. Now, if we can look at angle D1 and D2, they are on a straight line. It's angles on a straight line. So we know that angles on a straight line, they add up to 180. Angles on the straight line, they add up to 180. So we have D1 and D2 giving you angle D1 plus angle D2, they give you 180. What's your reason? Angles on a straight, however you write straight line. You just write angles on a straight line. And then now, if we look at angle A and angle D1, what can you conclude from angle A and D1? Remember from the previous theorem that we've done, we said the opposite angles of a cyclic quad, they add up to 180, the interior opposite. So now angle A is opposite to angle D1. That means both of them, they add up to 180. So now we have angle D1 plus angle A equals to 180. What's your reason? It can be opposite angles of a cyclic quad. And then now it's time for you to do the math. If you take D1 to this side, you're going to have D2 equals to 180 minus D1. Let's solve for D2 now. From the first equation, this one is your first equation and then this one is your second equation. So we are solving for D2. D2 is equals to, you take the D1 to the other side, you have 180 minus angle D1. You see? And then come to the second equation, you solve for A. You want A now. And then angle A is equals to, take the D1 to the other side, it's going to be 180 minus angle D1. Is it clear? Therefore, now you can conclude that angle D2 is equals to angle A. Therefore, angle D2 is equals to angle A. They are both equals to 180 minus D1. Both equals to 180 minus angle D1. So you have proved that D2 is equals to angle A. This angle D2 is equals to angle A. So the theorem that states that an exterior angle of a cyclic quad is equals to the interior opposite angle of a cyclic quad stands, or it's valid. So a short reason for this one, I guess, it's x angles of a cyclic quad. So your short reason for saying D1 and A, they are equal, is exterior angles of a cyclic quad. Let's look at some examples based on the theorem that says an exterior angle of a cyclic quad is equals to the interior angle opposite of that cyclic. So we can see E, B, C, D, they all lie on the circumference of the circle. That tells us that DCBE is a what? Is a cyclic quad. And then we have exterior angles. This is the exterior angle and another exterior angle. So now we are asked to find X and Y. X is an exterior angle, but they're telling us that we know that X, or the exterior angle, is equals to the interior opposite. So it's equals to the interior opposite. So X will be equals to 95. X equals to 95 degrees. Your reason is what? Exterior angles of a cyclic quad. And then you have Y. So we know that the exterior angle of a cyclic quad, this is the exterior angle, is equal to the interior opposite. You see, 70 is equals to Y. That means Y is equals to what? 70. Your reason is still what? Exterior angles of a cyclic quad. Thank you guys for watching. Don't forget to like, subscribe. I see the number of views are more than the number of likes. So please guys, show some love. Like, subscribe, and share with your friends that you think they might benefit from this. Thank you so much.